All right, hi folks, this is Larry Maslino. I wanted to record another video to help with the Module 3 MyLabs homework. So this is part 2 of some homework assistance. And so let me do some of the examples here towards the end of this homework. This is number 24 in the homework, and it says the curve y equal ax squared plus bx plus c passes through the point 1 comma 5 and is tangent to the line y equal 3x at the origin. Find a, b, and c. All right, well, I know this graph is a parabola, and it's telling me that it's passing through the origin. So I can draw a kind of a graph. That's always a good idea to get a visual picture of what's going on. So it says it goes through the origin, and it also goes through the point 1, 5. So here's 1 and here's 5. Let me draw a better parabola. That one isn't too good. That one's not good either. So let me do one more time. I got to practice this. Let me do it like this and like this. Okay, that's good enough. So here's the point 1 comma 5. That falls on the graph. And the line y equal 3x is tangent at the origin. So there's a line that goes like this. That's y equal 3x. Well, let's see how we can figure out the values of a, b, and c. First, let me use the point 1, 5. So I know the graph goes through 1 comma 5. That means the x value is 1. The y value is 5. So let me plug those numbers in. 5 equals a times 1 squared plus b times 1 plus c. So it looks like I'm ending up with 5 equals a plus b plus c. All right, well, this is going to help us to find the values of a, b, and c, but it's not enough to uniquely determine a, b, c, so we need another equation. Well, this parabola, this red graph, goes through the origin 0, 0. So let me do the same thing with 0, 0. So we know this graph goes through 0, 0. So that means 0 equals a times 0 squared plus b times 0 plus c. From this equation, we could say c equals 0. So we know c equals 0. Well, if c equals 0, then 5 is a plus b plus 0. So 5 must equal a plus b. But we need one more equation to uniquely determine a and b. Well, let's use the tangent line. If I take the derivative of y, so y is ax squared plus bx plus c. If I take the derivative, when I take the derivative of x squared, I get the result 2x. So it's going to be a times 2x. The derivative of x is just 1, so that's b times 1. The derivative of a constant here is 0. So what I'm ending up with is y prime equals a times 2x plus b. But remember, y prime is the slope of the tangent line. And at the point 0, 0, when x equals 0, the slope is 3 based on this line that they're giving me. So from that, I can write 3 equals a 2 times 0 plus b. Well, that means b equals 3. But if b is 3, I can come back to this equation and conclude that a must equal 2 then. We're going to replace this b with 3, so a equals 2. So now I have my results. A is 2, b is 3, c is 0. So I really use the fact that this parabola goes through these 2 points. I'll call this point A and point B. And then I use the slope of the tangent line for a third equation. All right, let's look at another example here. How about number 25? So this one says find all points on this graph that have tangent lines parallel to this line y equals 7x plus 6. All right, well, why don't we find the derivative of this function? Let's do f prime. The derivative of x squared is 2x, so that's going to be 2 times 2x. The derivative of this x is 1, so that's going to be minus 5. So the derivative here looks like it's 4x subtract 5. All right, but remember, this derivative is the slope of the tangent line. Now they're telling us that the tangent line is parallel to this line. This line has a slope of 7. Well, parallel lines have the same slope. So that means the slope of our tangent line should be 7. And so I want to find the x value where this happens. So let me add 5 to both sides of this equation. 12 equals 4x. So divide both sides by 4. It looks like x equals 3. That's the x value, but they want an ordered pair, so they want the y value. Well, I know I can take f of x equal 2x squared minus 5x, and I can replace f of x with y. Remember, f of x and y mean the same thing. They're interchangeable. So to find the y value when x is 3, I'll just replace x with 3 in this original function, this original equation. So this is y equals 2 times 9, subtract 15. Y equals 18, subtract 15, so y equals 3. It's just a coincidence that the x and y values are the same numbers. So the answer here is 3, 3. Okay. And by the way, if you were to think about this from a graphical standpoint, what they're telling me is this graph, y equals 7x plus 6 is here, let's say. This graph at the point 3, 3 would have a tangent line. I didn't draw this very well, but let me redraw this. This tangent line for the curve would be parallel. So maybe our graph does something like this. So at this point, the tangent line would have the same slope 7 as the original line, be parallel. These two, the tangent line and the line they gave us, are parallel lines, which mean they have the same slope. All right, let's see, here's 26. This is the last problem. It says find an equation for the line that's tangent to the curve at negative 3, 0. Graph the curve and tangent line together. And then there's also a part C. All right, well, let's find the derivative of this function. So y prime. I'm going to find the derivative of x to the 3. That's going to be 3x to the 2. By the way, folks, there's a derivative rule that says when you want to find the derivative of x to an exponent, you bring that exponent n down in front of x as a multiplier, and then you copy x down, but make the new exponent 1 less than what you started with. Let me give you a quick example here. How about the derivative of x to the 8? You bring this 8 down in front as a multiplier and make the new exponent 1 less than what you started with, so x to the 7. This is a big shortcut rule so that you don't have to use the limit definition. Because if you use the limit definition to find the derivative of x to the 8, that would be very, very time-consuming and messy. So we'll use the shortcut. All right, let me also take the derivative of this x here, which is 1. So that's going to be minus 1. Well, we want the slope of the tangent line at x equals negative 3. So I'm going to evaluate this at x equal negative 3. And when I do that, the answer I get is the slope of the tangent line. So the slope of the tangent line is going to be take this derivative function and evaluate it when x is negative 3. So this is 3 times 9, subtract 9. That's 27, subtract 9. That's 18. So this is m, the slope of the tangent line. But they want the actual equation of the tangent line. They don't want just the slope, they want the actual equation. So for that, I can use y minus y1 equals m, x minus x1. This is the equation of a straight line from algebra. Our x1 is -3, and our y1 is 0, according to this point they gave us. So y minus 0 equals the slope 18, x subtract a -3. Well, that's going to be y equals 18x plus 3. Well, that's going to be y equals 18x plus 54. So this is the answer to part A of the question. All right, and now it says, which is the graph of the curve and the tangent line? Now, what I could do is I can go to a graphing calculator and graph the function and the tangent line, on the same graph. But I can probably figure out by looking at these graphs which is the correct answer by elimination, by process of elimination. What I'm noticing here is the slope of the tangent line is positive 18. That means the tangent line is an uphill line, right? If the slope is positive, then the tangent line is going uphill. Well, this tangent line is going downhill, so this graph must be wrong. This tangent line looks like it's horizontal. That means the slope is 0, so this graph must be wrong. Here, the tangent line is going downhill. This graph must be wrong. This is the only graph here, graph D, where the tangent line is going uphill, so that must be the correct answer. And again, I could graph this on a graphing calculator to confirm that's the right answer. All right, let's do one last part here. It says, use your calculator to find the coordinates of the other point where these two graphs intersect. Well, here was the point -3, 0 that they told us about. But if you notice up here, there's another point where the two graphs intersect each other. And they're asking us to use a calculator, meaning using a graphing calculator. Well, I'm going to do that by going to Desmos, www.desmos.com. You can use that as a free graphing calculator. And I'm going to plot the original equation and the tangent line equation, and then see where the two graphs intersect each other. So let me go and do that. I'll come over here to Desmos. And again, this is a free graphing calculator. All you have to do is go to this input box on the left-hand side here and type in the function. So the original function was x to the third minus 9x, so that will be the red graph. The second graph is the equation of the tangent line, y equals 18x plus 54. That's the blue line. All right, let me zoom out a little bit here so you can use the zoom in, zoom out button. So I'm going to zoom out. You can also drag the graph with your mouse to get a better view. And so let me scroll up. Here's -3, 0 that we know about. But we want to find this other point way up here where the two graphs intersect. And if you notice, it's going to be right here. I'm going to zoom in to make it a little more obvious where the two lines intersect. So I think you can see the intersection point is right here. And it's a little hard to see, but 6,162 is going to be the answer. There it is, 6,162. Okay, and if you go back to the problem, that's the answer they're looking for. All right, hope this is helpful as you're working in the Module 3 homework.